Oh, hello. Unit 1, Day 9, Rule of Sum 2.4 from the textbook. So, as we continue through data management here at HP Bill Secondary School, I'm Mr. Lupos, and today's lesson, you're not going to learn much new, which is all right, I guess. So, we're talking about the Rule of Sum, and you guys did a little investigation in class, and let's kind of skip over that and just talk about what the rule of sum is all about. So the rule of sum really is if you have a situation where you want to figure out the number of ways to count something or the number of ways to do something, and there are 2 or 3 or 4 different scenarios, you just find out the number of ways to do scenario 1, scenario 2, and scenario 3 or whatever, and you add them together to find the total. So for example, if I'm going to take a family picture, so I'm going to take a family picture, and there are 6 members, including you in the family. So there's 6 of you, okay? There's 6 people, okay? I was going to draw them, but I'm not going to bother. And you're going to stand in a row, and you're going to take a picture, okay? Now, if you, there's 2 different scenarios here. Here's scenario 1, and here's scenario 2. Scenario 1 is you hold the camera and take the picture. You don't trust anyone else. So you go ahead and you take the picture, and scenario 2 is you have a timer, you put the camera down and you take a picture using the timer. So 2 different situations. In the first one, there are 6 members of the family, but only 5 of them will be in the photo, okay, because you're gone, which means there are 5 factorial ways to line those people up. So 5, 4, 3, 2, 1, multiply these, 20, and times 3 is 60, and that is 120. Okay, so 5 factorial ways there. What happens if you hold the timer? Sorry, if you use the timer, well, you're now in the photo, and then if you want to talk about what this is all about, that's going to be 6 times 5 times 4, which is really 6 times 5 factorial, which is 6 times the size of this, right? So 6 times 5 times 4 times 3 times 2 times 1, which is going to be 6 times of this, which is 720, okay? Which is amazing, eh? If you add 1 extra person in the photo, you now have 720, you've gone from 120 to 720 different ways you can order the people, which is really fascinating. Think about that. Okay, so that's that. But the question is, how many ways in total can you take a family picture? So you can have a family picture with 5 people or 6 people in it. And what you do, very simply, you don't do anything crazy with this stuff. You have 120 ways to do this, 720 ways to do this. So scenario 1 has 120 results. Scenario 2 has 720, and you just add them up, and you get 840 ways to do both. There's no way to do these questions at the same time. You know, you don't have a scenario where you say, okay, where does the person go? He either goes in or out type thing. It doesn't work that way. Okay, just look at the situation and say, I can be in the photo. I can be out of the photo. I can be in the photo. Those are 2 different things. Find out the number of ways to do it, and then add them together. Okay, here's the deal. I have a bunch of books on my shelf at home, and I don't read them because I'm not very good at that sort of thing. So what I want to do is throw them on a bookshelf and look really smart. So when my friends come in, they go, "Wow, you're bright." Okay. So I have a bunch of books that I found, and I put them on the shelf, and I look at the shelf, and I can either fit 11 books or 10 books in there, depending if I want to jam them in or not. And you ask yourself, how many different ways can you fill up your bookshelf? Well, just 2 different scenarios. One is 11 factorial different ways to do that, if you use 11 books, and the other is 10. Okay. So nothing crazy there. That's the rule of sum. If you go, that doesn't sound like much. Well, it doesn't. Okay. You're drawing 5 cards from a deck. How many ways could all the cards be black or all the cards be face cards? Okay, so let me all the cards be face cards. Okay, so 2 different situations you have. They can all be black or they can all be face cards. Okay, now we do have to be careful here. Is there any overlap? Well, let's get to that in a second here, because there might be overlap. But let's slow down. So one is you're going to choose. And you're drawing the cards. So the order here, we're still in this part of the course, order matters. Okay. In section 3 of the course, order will not matter. So it matters. You flip a card, and it has. So if I go 7 of clubs and then 8 of clubs, that's different than 8 of clubs and 7 of clubs. Okay. And then it gets even more extreme when you have 5. So this is from yesterday. We use this notation here. There are how many black cards in a deck? Half of them, so they're 26. So it'll be 26. 5 out of 26 permutations here. So how does that work? 26 factorial over. Remember how we worked this out? 26 subtract 5 is 21, 21 factorial. What's that equal to? You can put them in a calculator. The other thing is you can just kind of cancel out and just find out what this is, 25 all the way through here. And you stop at 21, because once you get to 21, on the bottom here, you have 21 factorial, right? Because again, once again, let me just go over this. This is 26 times 25 times 24 times 22 times 22 times 21, and keep going. All that is the same as that. It's gone. So figure out what that is. Multiply to figure out what that is. And then phase cards. You want 5 phase cards? Well, how many phase cards are there? There are, now, they're not black phase cards. They're total phase cards. So we know that there are 12 phase cards, right? There's 4 jacks, 4 queens, 4 kings, and you wanted to choose 5 from there. So you're going to figure out what this is, you're going to figure out what that is, and you'll add them together. Okay? Now, is there any overlap? Can you have a situation where there are 5 black face cards? There are. Now, what does that mean? That means I chose a horrible question, because I don't want to get into to just having 5 black face cards. So there would be overlap here. So what I will do in the future is remove this question from the note, and I just realized how bad a question this is. Okay? So I forgot about, I kind of thought to myself that you only have 3 face cards that are black, but that's not true. You have 3 kings and 3 queens. Well, we can work this out. Why don't we do this? I mean, I meant to do this. I take it all back. How many different combinations are there of black face cards? Because you've doubled them up now, right? You counted them with black cards. You've counted them here with face cards. I can't believe I did this on purpose. Okay, so what's this going to be? How many black face cards are there? 6. And how many are you going to choose? 5. Okay, so here you have this and you have this. You add those together and you subtract this. This is just a small number. It'd just be 6 actually. Okay, so there's 6 different combinations where you choose black face cards that you've double counted. Okay, great question. Thanks. Next, you're taking a picture of your 10 favorite stuffed animals. Wow. It's not that you have 10 stuffed animals, it's that you have 10 favorite stuffed animals, which means one thing, you have more than 10 stuffed animals, and 2, you rank them. Strange. 10 favorite stuffed animals. How many different pictures are possible if there are no restrictions with all animals in the picture? So here, all the animals in the picture are 10 factorial. Just line them all up. Okay, so excuse me. That's one situation. Okay, we're lining them up. It matters. You know, you have the purple one here, and then you have the yellow duck. I don't know. That's not a yellow duck, but you have them in order. They're all different. Okay, so 10 factorial. Here's a different situation. You could take a picture with any 10 animals or one which excludes the 4 blue ones. Okay, so here's the 10 animals. It's that, and the 4 blue ones are gone. So the 4 blue ones are gone. Real simple. All you do is throw them out the window. You don't have to throw them out the window. All you do is say, hey, sit over here. And you put them over there. Odds are you are talking to your stuffed animals. If you have them ranked, you probably also talk to your stuffed animals. So you have the 6 non-blue ones, okay, and you put them in order. So here is scenario 1 with all the stuffed animals, and scenario 2 is the 6 non-stuffed animals get together. So all you do is add them together. How about this? This is a really good question. The 2 lions must sit together. So you have 2 lions. They must sit together. So what happens now is, we did this earlier, yesterday, with the note. And what you do here is you have lion 1 and lion 2. That's what we call them. And you put them together, and they're almost one entity. Okay. So you have 2 different situations, though. One is where you have lion 1 first and lion 2 second. Okay, we're saying this is the beginning, this is the end. And basically what you do is, this is now one giant stuffed animal because they're attached together kind of. And then you have, think about this. You don't have 9 other animals. You have these 2, and then you have 8 other non-lion animals. Okay. So what you do is, you can look at it 2 different ways. One is, I'll do this 2 different ways. One is to say line 1 goes first and line 2 goes second, and then you line these guys up. So this is just, there are now 9 stuffed animals in total, kind of, right? This giant double lion and the 8 other ones. So it's just 9 factorial. Now, that's if line 1's first and line 2's second. You will add to that the same number once again, because you could also have the scenario where line 2 is first and line 1 is second. Another way to do this is to say, I have 2 different things to do. First of all, I want to figure out, well, let's do it this way. Let's just figure this out first. Okay, let's put all the animals in order first. I have 9 factorial and put them in order. But within that, I have this double lion thing going on here. And because there's 2 of them, there are 2 factorial ways to order the lions, which 2 factorial is just 2. Okay, so what you're doing here is you're lining these 2 lines up, and you go 9 factorial times 2 factorial. That's kind of neat, right? Or you can even look at it a different way and say, let's line the lines up first, 2 factorial ways. And let's multiply that by 9 factorial now that the lions are this giant entity, plus the other 8. That's 9 stuffed animals, and put them in order that way. All these are the same. Either 9 factorial twice, 2 times 9 factorial, or 9 factorial times 2 factorial, or this here. Okay, so kind of a neat question, I think. The mouse and the cat must not be each other. Okay, so this is really neat. And this one's hard to do if you, and that's why I wrote here kind of a hint here, indirect method. So what's going on with this one is the mouse and the cat cannot be together. You can't really answer that question directly. That's why it says use indirect. What you're going to do in this when you have a can't, okay, or not be near each other, is you're going to figure out how many total ways are there, and then how many total ways are there where the cat and the mouse are beside each other, and subtract the two. Okay, so you're going to do the total, and you're going to subtract from it the total where cat and mouse are beside each other. So let's go over that first. First, the total is 10 factorial. We already said that. Remember, we have all 10. And then this one here, where the cat and mouse are beside each other, well, that's the same as the two lines beside each other, right? So that's going to be how many different, if we insist that the cat and mouse are beside each other, there are 2 factorial times 9 factorial ways here, or 9 fact, any of these. These are all the same thing, okay? So what you're going to do is find out what this is and subtract from it the number of ways where these two guys are side by side. So again, why is this in this order? Oh, sorry, why does this become this? Okay, you have cat and mouse. They can be ordered in 2 different ways, or 2 factorial different ways. Once they're ordered together, they are now kind of a, like a big stuffed animal that's, you can treat it as one entity or one member of your group here. And now you have this big guy and not 8 other ones, sorry. 8 other ones. And now we're going to order these 9 things together. So 2 factorial times 9 factorial. Subtract the 2. Okay, the frog must be at the end. Okay, so you want the frog, oh, what's going on here? You want the, no, second. You want the frog to be at the end. Okay, so the frog is at the end. Well, you haven't said which end yet. So we have 2 different scenarios here. One scenario is where he's first. So the frog goes first, and then you line up the other 9. So you have 9 factorial ways to do that. Okay, so if the frog is here, the frog is only in one place. So it's actually, you can think of it this way. It's 1 times 9 factorial. Or you put the other guys like this, and then the frog is second, and then you're going to add to that this situation where it's also, again, 1 factorial times 9 factorial, or what is going on here is 9 factorial times 2, or 9 factorial plus 9 factorial, okay? The other thing you do also is you can, say, treat the ends like a thing and say, I have 2 choices here, 1 or 2, right? And then I have, if after I've made that choice, I have 9 choices for the other animals. So that's another way to do it this way, okay? So you're going to add 9 factorial to itself there. So the lamb must be in the 8th position. So there's nothing special about the 8th position. It's the same thing as being at the end or the 10th position. But let's look at this and say the lamb goes here. So there's 2 other guys here. And that means that there are 7 on this side. Okay. So this is kind of straightforward. Really, if the lamb is here or the lamb is anywhere, it doesn't really matter. The lamb's gone. Okay. So now you're lining everyone else up. So who goes here? Well, there's 9 choices, 8 choices, 7 choices, 6 choices, 5 choices, all the way down. So once that lamb is stuck, the lamb is gone. It's just 9 factorial ways to do everyone else. Okay, all these questions are a little bit different. I think they're neat. I think you'll like them. Okay, so give it a shot, and that's it. Take care. Bye.